Hello, welcome back to an episode of Beam There, Done That. Again, I'm your co-host, Alan Wyma. So this is the podcast all about building real systems on the beam. No hype, no theory, only experience. And I'm here with my co-host, Francesco Cesarini.
Hi, I'm Francesco Cesarini here with Alan Wyma. So, really exciting episode today. We're going to the place most people think of when they hear the words Erlang and scale in the same sentence. It's WhatsApp, a messaging system that has served a meaningful fraction of the entire planet for years, on the beam, of course. And we've got two of the engineers who work on the team which help it, which keep it running. This one earns, the planet scale in the title, so stick around. What I want to get into today is what that looks like from the inside and what it looks like now, because it's still Erlang, it's still at scale, almost no one else operates. And the work has moved on into tooling, into types, into keeping a code base that size healthy. It's not an easy feat. And what makes this episode exciting for me is the fact that we used to meet up with Jan Korum and Brian Acton, the WhatsApp co-founder, in coffee shops in Mountain View. At the time, when we were meeting, there were only three in the company. They had no office, they had no investments, they had a vision and a hint of stubbornness. Today, we have Roberto Aloi and Michał Muskała. Roberto started his career at Erlang Solutions with me, whilst Michał and I go back from the time he was actually doing Elixir, before joining WhatsApp. And he's one of the early developers who, from starting his career in Elixir in its early days, moved over to Erlang. So welcome to the show, both of you. Tell our listeners who you are and what you do at WhatsApp.
I'm Roberto. Thanks for having me. Been in the Erlang community for quite a bit, around 20 years now. And in the past few years, I've been focusing on developer experience, and that's what I'm doing at WhatsApp and Meta.
Hi, I'm Michał. As Francesco mentioned, I started my career with Elixir, but then moved on to working with Erlang and on Erlang at WhatsApp on the same team with Roberto, focusing on developer experience, but also a bit on the virtual machine, the language, and anything that can make our engineers more productive.
So, thank you both for being on the show. We start every episode with a scar. And Roberto, you've spent years deep in Erlang, deep in the trenches, in the internals, with toolings and programs that read other people's code. What's a production fire or a bug buried in someone else's code that taught you something no amount of reading the docs or the specifications would have helped solve?
Yeah, that's a tricky question. Been many bugs and many production fires where someone else's code is your own code, usually. I think one that I remember from previous company was the usage of Erlang stack trace deep into the code. And there was like one Erlang OTP release where I think column numbers were added for the first time. And that had a massive effect on a negative effect on the performance of a function. And this caused, when a crash was happening, like cascading effect that was super tricky to figure out.
So Michał, you've been working a lot in making Erlang and Elixir faster. You've done a lot of work with JSON. What's an optimization that you were certain would help actually make things better, but actually made things worse?
Yeah, that's a great question. I think anybody who've done kind of major optimization work will probably tell you the same, that probably like 95% of the ideas that you have for making things faster actually make things worse and make them slower. But I think one thing that stands out to me, kind of thinking a bit more about that and kind of the story around JSON, was handling of, for example, handling of Unicode, where I thought that, transitioning to using binary pattern matching and like the native UTF-8 car matching would make things faster. But in fact, it made them slower. So in JSON and then now in the native OTP JSON library, I re-implementing a custom state machine for parsing Unicode that ended up being faster. But I spent a lot of time investigating why is the native stuff not fast enough. And there's certain trade-offs that make it faster in certain situations, but definitely not for this kind of batch validation that I needed it for JSON.
Let's start with how each of you got here, because you came into the Erlang ecosystem from very different doors. Roberto, you started with Erlang at the University of Catania. What was the moment Erlang clicked for you?
So that's an interesting story. So Erlang was not part of the standard curriculum at the University of Catania, which is in Sicily. We had this side project where we were building this robot to take part into some kind of competitions, and the core of the robot was written in Erlang. So as a student, the first task that I got without knowing anything about Erlang was to essentially implement a GenServer. So I got a little device which had like a small screen and 6 keys that you could press. And I could connect this little device to my laptop through a serial port. And I had a GenServer that at that time I had no idea how, through some kind of like black magic, it would get these messages directly. Like I would press a button on the device and I would get a callback function invoked and handle info with some kind of message. And I learned about the binary pattern matching, and it almost felt like cheating, because when you implement this kind of functionality in a lower language like C, you have to do a lot of decoding and encoding. But here it felt like, okay, I need to take the first bit, and this is the variable that holds the value, and these are the next 2 bits, and it really felt like cheating. And on top of that, whenever my little process, my GenServer, had a bug, had a crash, the whole thing was automatically restarted. And that's how I got to learn about supervisors and that felt, again, like magic.
Was that the year Erlang Solutions was sponsoring the robot?
Yes. So I think we had like a very limited budget at that time. So we were looking for sponsors. And I think that's one of the reasons why we were looking into Erlang. I think nowadays, I don't believe they still build robots. I don't believe they use Erlang anymore. They probably switched to Python, but someone should really tell them to look at NURBS and Elixir and all that. I think it would be extremely fun for the project and the students there.
Now, Michał, right? You came like the other way around, right? Usually a lot of people come from Erlang and move on to Elixir, but you came from Elixir and went down to Erlang, right? After working in Elixir and going to Erlang, what kind of things actually surprised you? Because to me, Elixir has a lot of niceties to it that Erlang didn't have, because of just, this came out much later, so benefited from coming out later, right? So what came from your side?
Yeah, I think that's a good point, and I would say kind of the tooling and the ecosystem was initially a bit of a challenge for me, particularly around coming from Elixir, being used to modern tooling. A lot of Erlang tools felt more classic or old school, I would say. So this was a bit of a friction. I think another part that was challenging to me in the beginning was the type of code you tend to write, or you mostly see in both languages. Elixir usually deals with web systems and kind of, again, those kind of stuff you would see in most modern languages today, right? Very similar APIs, kind of web servers, web APIs, and things like that, versus working with Erlang. It's much more systems programming, much more low level, kind of what I like calling C-style code. So that was also a bit of a difference. That's kind of where we got off to. But seeing that and kind of bringing this experience from Elixir to Erlang allowed us to work on the tooling and on the infrastructure and improving it, and then contributing to the open source community to bring things up to speed to where we are right now, where I personally would say that the Erlang tooling right now feels better than the Elixir one.
So when did each of you first run into WhatsApp scale engineering? The thing that's different in kind, not just a degree. And just as a side note, I think, WhatsApp scale engineering is a word which will probably, which is in the dictionary, in the vocabulary of every Beam developer. So Roberto, you first.
Yeah, so when people talk about scale, WhatsApp scale, they usually refer to the runtime. I guess the type of scale that me and Michał are exposed to is a different kind of scale. Is the scale of the code base, is the scale of the people working on a project, and the kind of corner case that you get. When I joined, one of the first projects I was involved with was to take the existing language server, the thing that helps you to write Erlang code and have a decent IDE experience, and to make it work. And the language server was kind of okay and working well for most users out there. But then when you start to use it at WhatsApp scale, you start to see all the corner cases and all the scalability problems that come with like a more massive code base and so on, and several people using it in very different environments. So that was the first experience, I guess.
Yeah, for me, so kind of, I guess, first experience, kind of thinking back to the first project I worked on at WhatsApp, which was the ErlFMT, the formatter for Erlang. I think that the Roberto talking about the scale of kind of engineering and the scale of the team was very visible to me, since kind of formatters are divisive projects, especially when you have, a lot of very experienced engineers with strong opinions, and kind of marrying those opinions and then making sure that one, it works on the entire code base with all of the edge cases and weird things you might find in the code base at the kind of the size of the code base. But two, making sure all the decisions are well reasoned and kind of can take everybody on board with you. That's been kind of a challenge.
Yeah, I mean, WhatsApp scale is a phrase in the vocabulary of every Bean developer, and you have given a new meaning today.
Now, did either of you imagine going in that developer tooling would become the strategic problem at WhatsApp, or would you just think that this is running on the Beam and I need to do actually very much?
Well, I guess we were both hired exactly for that reason, so it was not a surprise. So there are like many developers at WhatsApp that use Erlang as a core component. I think it makes sense for a company like this to invest in the language in the ecosystem so that you have a healthy environment. And likely a lot of what we do can be upstream so that other companies and the overall open source community can benefit from them.
Yeah, as Roberto said, we were both hired exactly for that role to work on developer tooling. And I think one of the unique things about working here is that, we not only have metrics and measurements around all the production stuff that you'd normally expect a company to have, but we also have a lot of metrics and measurements around how engineers use the developer tooling. Are there any issues, errors, bugs? We kind of treat the developer tooling as a production system, so we can iterate, optimize that, and work on that.
Let's bring everyone up to speed on why Erlang became foundational for systems like this one. Roberto, how did Erlang become the language of choice at WhatsApp?
Well, I guess that was definitely way before our times at WhatsApp. But you probably know, I guess the original WhatsApp team stumbled into this thing called eJabberD, and they started building something, and they accidentally maybe they just found the perfect tool for the job. They started using Erlang, they started using the Beam. Everything worked perfectly fine. There was no reason to change really.
I mean, Erlang is basically what gave WhatsApp the whole first mover advantage. When they were done with it, there was not much of eJabberD left because they had to optimize a lot. But yeah, they did indeed start with it, and they started optimizing the VM. And there's a long list of really, really interesting talks online for those who are curious about it. So messaging looks almost perfectly aligned with the actor model. A process per message, a process per conversation, a process per user, messages passing between them. Was that fit obvious from day one, do you think, for them? Or is that a story of people tell afterwards?
I think it's a little bit of both. I do think there's probably quite a bit of explanation based on that. I think what Roberto mentioned, that kind of they found a system that worked well and started going with it, was a big part of it. If I look at the system kind of today, it's definitely that Erlang fits our needs very well, and we continue to believe in the platform and then build on top of it. And we're very happy with where we are today.
So as you start climbing towards hundreds of millions and hopefully billions of users, which properties of the Beam actually become more valuable, and which of them actually stop paying off, right? Maybe you had quick wins with this, but now you have to change to something else.
Yeah, so definitely kind of the process isolation and message passing, that kind of scales with the system and doesn't, as it was useful when the system was smaller, it continues to be very useful today. What kind of is becoming, I think, more and more useful for us is definitely observability and tracing and kind of those things to get there. One thing that you mentioned that might be a thing that is less useful nowadays. When I joined WhatsApp kind of around 7 years ago, we were still occasionally using hot deploys for pushing code to production. However, as the team scaled, as the rate of change scaled, of the system, this became less and less practical because it required kind of extensive planning and understanding to be able to do this kind of change. So it became more of an emergency workflow, but it's not part of our everyday practice using hot code loading.
Facebook, when you do upgrades, and I don't know if this applies to WhatsApp as well, but what they do is they first upgrade a small subset of the servers, they monitor them. If everything works, they'll go in, so they'll first update maybe 1% of the servers, and if it works, they'll go in and update the remaining 99%. Is that the same at WhatsApp today?
Yes, this is pretty much exactly what we do as well, where we kind of first roll out into kind of a certain amount of servers, then into one region, and then kind of roll out into the rest of the regions, kind of monitoring how the system health looks like as we roll things out, and then we're ready to roll back whenever if we find any issues.
What about for hot code upgrades? I mean, does that become more difficult the more scale that you have?
So I don't think the problem per se is the scale of the service and kind of how many servers and how many users you serve. I think the problem with hot code upgrades is more on the engineering side and kind of engineering practice. Because doing the hot code upgrade, you need to have a very good understanding of your code base, kind of what things you can easily upgrade, what things you cannot easily upgrade. And kind of as the engineering practice scales, and you try to deploy every day or sometimes multiple times a day, keeping this discipline becomes less practical.
Roberto, here's one I really want your answer on. What is the most misunderstood thing outsiders believe about Erlang at WhatsApp?
So I guess people have assumed that robustness and scaling are the kind of hard and exotic part. Erlang OTP and the Beam, all the libraries give you an excellent starting point for solving that problem. So essentially, a lot of the engineering work is done on the business logic side. You have your logic into very isolated portions of the code, and that simplifies things a lot. Also, it is true that the Beam provides a very good starting point, but it's also true that you also need to do a lot of work to make things scale. So a lot of contributions came from WhatsApp in terms of the dist protocol and the PG and memory and all that. And luckily, a lot of what we do was something that was possible to upstream and including Erlang OTP itself. So that helped. So also one thing is that people probably imagine is that you have a lot, a massive amount of Erlang expertise, which of course it's there as well, but it is also true that a lot of the people working on the WhatsApp code base didn't have necessarily a prior Erlang experience. So it's something that you learn as you go. So that's kind of a lesson learned from this, that if you have your company, if you want to launch an Erlang or Elixir product, probably a good advice would be to not necessarily hire for Erlang or Elixir engineers or developers. You want good developers, good engineers, and you want to teach them Erlang and Elixir and the other languages.
I think Anton Larvik, employee number 30, was the first employee at WhatsApp who actually had operational experience with Erlang. So, it tells a strong story. People complain, oh, we can't find Erlang developers. Oh, we can't find Elixir developers. No, you don't need Erlang or Elixir developers. You need, good developers. And the fact that the 30th the 30th employee at WhatsApp was the first one who had Erlang experience, I think says it all.
If scaling is not the difficult part, right? What is actually the difficult part that you need to deal with on a somewhat consistent basis?
Don't get me wrong, scaling is the hard part, right? It's definitely making sure the system runs at this scale reliably is our number one task and our number one responsibility for our engineering team. But I think scaling in many cases is not necessarily what you think about it in terms of number of servers and things like that. Is, for example, also scaling and making sure the Beam runs well on different types of servers, different hardware that we might need to support. So there's a lot of different aspects to scaling that turn to this. And then again, it's kind of not necessarily. It's also always the size of the code base and the complexity of the code base and the complexity of the system that is also making it something that you need to pay attention to make sure it again runs reliably at scale.
Now, at the scale, what types of failures, just become norm? The things you stop treating as emergencies, and stop getting out of bed for.
So you have all the usual things like bad configurations, like crashes, bugs in the application logic. Those are coming basically like a constant rate. So a very good practice that helps in those cases is disaster recovery drills. We do a lot of them. So that essentially you can simulate issues and ensure that all the pipelines, all the procedures, everything like the disaster recovery procedure work. So whenever there is a real emergency, then you are prepared. And I think that's one of the big learnings from working at WhatsApp.
Which this Roberto, gets us onto the phrase everyone quotes, but not everyone understands. We'll ask Michał here. Michał, what does let it crash actually mean in production, at WhatsApp at this scale?
Yeah, so I think let it crash is not kind of long enough or precise enough, right? Because it's fine to let it crash as long as the user doesn't notice, right? And I think the key element here is that letting things crash is fairly easy, right? You can do that in any language where the whole thing goes down. You just let it crash. The key part that's hard and that's somewhat easier on the beam and kind of where the beam shines is that the recovery is easier. So it's not only let it crash, but then also let it recover in a way where the system can continue in a healthy state.
Now let's flip it around, right? Are there parts of Erlang that get more elegant at scale rather than harder? Like, where does being huge actually help?
So I think when you operate at scale, both in terms of the code base and the runtime, there are a bunch of things that the company, the organization can invest into. So developing like developers tools is one of them, but also frameworks, libraries. So the idea is that when you reach a certain scale, you need to bring order in the code base. What you tend to do is that you have like part of the team that focuses on frameworks and guidelines, and you establish some patterns so that people can focus on their business logic. And I think that's exactly what's happened WhatsApp.
Let's move from why the beam fits into this to what actually bites. At your scale, what's the real bottleneck? Is it machines? Is it networks? Is it engineers?
Yeah, so I would say the system in terms of pure efficiency, I think we don't have many concerns that, and it's not something we usually focus that much on it. Though of course whenever we get any performance wins, that's always welcome. But definitely the side we're most kind of exposed to by kind of where we work in is definitely scaling the engineering practice and then the team and the approach, right? At this scale, when you have CI, CD, and then so many tests and flaky tests, how do you ensure this doesn't stop everybody from doing their work? Right. So, for example, to help with that, we have quite sophisticated system of detecting which tests are flaky and usually just disabling running them on pull requests or diffs, as we call them internally, and just filing tasks for the owning team to fix them out of band. And I would say to some extent, in terms of this engineering practice, kind of making this scaling this work with AI has actually been a bit worse rather than better.
Can you tell us a little bit more about coding agents making it worse? Because that's the opposite of what people expect.
I think what Michał meant is that agents are basically new teammates that start to contribute code, and they are extremely efficient, so they can write a lot of code, and they can potentially like stress your continuous integration, continuous deployment infrastructure, and so on. So you need to implement appropriate safeguards and checks so that you help them. Also, that means a new category of tools. For example, it is true that AI and agents are non-deterministic, but you can help them out with taking the deterministic parts, which could be running tests or lint your code and so on, and use scripts and tools like ELP or Equalizer that can drive the agent's work. There is also all the work around guidelines. Agents need to learn about your style of coding and you want to ensure that AI produces code that you would be proud of. And those are like completely new challenges in the industry.
Going back to what you mentioned, right, about if you have a really good solid engineer, you should be able to kind of onboard them to Erlang. As an Elixir engineer, it came from a Ruby background. Picking up Elixir is not necessarily super simple, but it's definitely not difficult if you already have a Ruby background. You can kind of pick up the syntax. But Erlang is kind of like a whole new beast. I'd say most developers don't even look at Prolog, definitely not look at Erlang. Onboarding engineers should actually start using Erlang on a daily basis. How difficult is that? Is that really a problem? Is there like a whole training school set up? How does WhatsApp actually onboard their engineers to do Erlang every day?
We don't actually have a very structured approach to this onboarding. So it's mostly up to teams themselves and kind of the person joining the team to help onboard them. And I don't think the language is kind of usually the big part of that or the hard part. It's usually getting understanding the code base and kind of the nuances of how it works, as well as understanding the operational aspects of the service that the engineer will be working on, kind of the on-call and kind of all of the workflows there. Those are usually the things that are much harder. I don't think Erlang is the barrier, and usually when we ask people and follow up with them, kind of what usual problems are, kind of Erlang doesn't pop up as one of the main things people focus on. And definitely in this aspect also AI is making things easier and kind of ramping up on the code base and contributing to the code base that you might not be super familiar with. It is actually easier to do those things, kind of leveraging agentic workflows.
So, Roberto, does Erlang still feel simple at this size, or is simple something which has been lost somewhere along this journey?
No, I think that simplicity is what Michał, and the rest of the team is trying to achieve all the time. We kind of hinted at this already. Like you want to take the code base and split like the core of the code base, the scalability, stability part from the business logic. So yes, the business logic can be complicated, but at least it's isolated. One solution to the simplicity sometimes is like generalization. So you want to give developers a way to write their code which adheres to your standards and things, but you also need to ensure that this generalization is actually useful. So it's not premature. You want to keep the code base understandable for both humans and AI. And yeah, I mean, keeping like a system this big, simple, it's definitely one of the challenges.
What operational lessons surprised you the most after joining WhatsApp, and the things you couldn't have known just from being on the outside?
Yeah, I think we already hinted at the disaster recovery practices. If you are not used to them, it's a new thing. It sounds scary, like you would basically simulate something that could potentially like affect the stability of the system. But overall, like I think if you get into the habit of doing this, you ensure that all the tooling, all the procedures are in place. And I think the biggest lesson there.
So how crucial is observability when you're debugging something distributed across that many nodes?
That's the key part, right? That's very much the essence of what we do. So for most of us, the teams that build the services are also the teams that operate the services. So we don't really separate the two. And so kind of having a good understanding of the code base when you see any issues, then kind of following up with tracing, alerting, logs, kind of having good visibility and good introspection into the system is key part of that. And this is, again, an area where Beam shines with kind of the power of tracing that we have. It's something that we leverage significantly. And of course, that's kind of the Beam tracing. We also have kind of application level tracing of requests and then things like that we can follow up to understand.
Let's get concrete on design. Are there architectural patterns which have worked for you, which you keep on reaching out for again and again?
So I would say definitely the one big pattern that we have is kind of pools of processes and kind of that communicate. So we have this framework called GenServer, GenFactory, That's kind of a pool of GenServers, and then Gen Industry, which is a pool of factories. But that's kind of this kind of pooling and kind of hierarchical setup of the system is definitely a piece that we find everywhere. There are some interesting parts to that. For example, using ETS tables for managing managing requests queues rather than process mailboxes, and kind of some recent developments in capabilities in the Beam, like the atomics module, and kind of building some sort of queue on top of the atomics. And that also comes back to so I wanted to follow up that also comes to kind of some capabilities we've worked with the OTP team to land in OTP 28, which are priority messages. So historically, we've had a lot of different workarounds and kind of approaches to simulate priority messages. But now with the native support, this has greatly simplified our system. And one area where, for example, where I can give an example of a place when you want to send a priority message in this kind of pooled system, for example, would be a worker sending "I'm done" message back to the queue coordinator, right? That you want to be handled before other requests for the service to keep things in balance.
Walk us through the ETS instead of mailbox choice. It's something we used very, very early on at Erlang Solutions. I think back in 2003, 2004 was the first time I came across it, because we've been using it, but it almost feels like it goes against the just send the message instinct and the whole instinct and idea of adopting concurrency.
Yeah, so I think this is definitely, we still use messages quite a lot for that, but where ETS helps is kind of offloading some of the memory operations, because with some bigger requests and then some bigger communication patterns, kind of the copying the message at each hop in the system can become quite expensive. So for example, if you just write it to an ETS table that the worker can read directly from, you can save on some of the copies. So it is a bit of a, I would say, operational or kind of sidestepping the semantics of the Beam because they don't fit that great in this particular pattern. But kind of with the tools that the Beam gives you with ETS tables, with atomics and other things, you can achieve good operational characteristics.
Coming back to the patterns, right? What kinds of anti-patterns can actually just reliably just create a lot of pain for you guys?
I think one of the anti-patterns we've seen is the usage of overly dynamic code. So Erlang is dynamic. You can do a lot of fancy things where you can basically call a function from anywhere, like an atom represent a function name or a module, and then you can combine these things. And this creates pain. Creates pain when you're debugging a system, when you're trying to understand who's doing what. It creates pain into the developer tools. It's very hard to make like static analysis when you have overly dynamic code. It's very hard for tools and humans to understand the code base and navigate and so on. So writing dynamic code is a blessing, but also a curse.
Let me pull this together. For most part of my later part of my career, when someone asked me whether Erlang really scales, I pointed to WhatsApp, and that ended the argument. What I'm taking away, from this interview, from this podcast, is that the answer was never that simple. It was the boring, durable things, process per connection, isolation, supervision, recovery rehearsed until it's routine, and the discipline to keep the simple part simple whilst the system got enormous. And the crash was always the easy part. The recovery is where the real engineering lives. Roberto, Michał, thank you to both. We started today in coffee shops in Mountain View, with Jan and Brian, and they're a very stubborn idea. And I think probably we're talking about 17 years on, we've ended up inside one of the best solutions the Beam has ever produced. And, this is a good time and a good place to pause.
Yeah, and again, pause is, the word, because this is only half the story. Roberto and Michał spend their days on, the part we've barely even touched yet. The tooling and the type systems that keep the code base size healthy. I don't know if it's called ELP or ELP, Equalizer, Earl format, all of it. And that's the next episode. And you'll want both, basically, to get the full picture of what's happening at WhatsApp. And if you're getting something from the show, please leave us a review on Apple Podcasts and Spotify Podcasts. It's the single biggest thing that helps us to find new listeners. And we'll see you guys next time on the Being There, Done That podcast.
Yep. Thank you all for being on the show, and thank you to all our listeners for listening. And for the record, this episode was recorded June 25th, 2026.